The evaporative emission, or evap purge solenoid valve, is used to purge fuel vapour from the evap canister to the intake manifold. This is an essential part of the modern vehicle's emission control system. The evap purge solenoid valve is pulse width modulated. The engine control module, or ECM, controls the solenoid valve by grounding the control circuit with a solid-state device called a driver. The driver may be equipped with a feedback circuit. The ECM can then determine if the control circuit is open, shorted to ground, or shorted to voltage by monitoring the feedback circuit. Ignition voltage is supplied directly to the evap purge solenoid valve from the ignition relay. This relay may be monitored for shorts and opens by the ECM. An open or excess resistance in the evap circuit may cause DTC P0443 to be set by the ECM. The conditions for running the DTC are ignition on and battery greater than 11 volts. Verify that the fault exists. If these are history fault codes, it may be necessary to use the vehicle's freeze frame data to reproduce the fault. Always confirm the battery condition and correct voltage before beginning diagnosis. Using a scan tool, navigate to the Actuations menu and operate the evap solenoid. The evap solenoid should make noise as the scan tool is commanding operation. To check the evap circuit, disconnect the solenoid and test for battery voltage on the supply terminal. Connect the multimeter between battery negative and the supply terminal. Turn the ignition on and observe the meter. Battery voltage should be evident. If battery voltage is not found, check for an open in the supply fuse. If the fuse is OK, test for correct voltage supply to the fuse holder and confirm the holder terminal tension is correct and no corrosion is present. If this is OK, then confirm the supply relay is functioning correctly. If battery voltage was correct and the fuse terminals had correct tension and no corrosion was present, there may be an open in the supply circuit. If there are any other connectors in the circuit, it will be necessary to locate and test for correct voltage at each one. With 1 metre lead connected to battery negative, back probe any connectors in the circuit at the correct terminal and note any change in the meter. A correct voltage reading on one side of the connector with no reading on the other will indicate an open in that connector. Systematically testing and confirming will isolate the open to a section of harness. With the ignition on and the evap solenoid disconnected, measure between the supply terminal and battery negative. If less than battery voltage is displayed, then there is excess resistance in that circuit. Confirm that correct voltage is supplied to the fuse and the terminals are free of corrosion and have the correct tension. Locate any connectors in the circuit and test for correct voltage at each one. Back probe each connector at the correct terminal and note any change in the meter. A correct voltage reading on one side of the connector with an incorrect reading on the other will indicate an excess resistance in the connector. An incorrect voltage reading before the connector indicates excess circuit resistance between that connector and the fuse. Because the ECM controls the evap solenoid with a PWM ground path, it is necessary to check this control with an oscilloscope or a multimeter. With the evap purge solenoid connected, back probe the control circuit with one channel of the oscilloscope. At the ECM connector, locate and back probe the control circuit with a second channel. Using a scan tool, turn the ignition on and activate the evap solenoid. A square wave duty cycle pattern should be evident on both channels. This signal pattern can be overlaid and any differences in the pattern can be observed. If the first channel displays 0 and the second displays the correct pattern, then there is an open in the circuit between the two connectors. If the first channel has a lower output voltage than the second channel, then there is excess resistance between the two connectors. As always, repeat these tests at any other connector in the circuit to isolate. If both channels have low voltage, then the excess resistance is in the ECM connector or ECM. If the pattern is correct, then the ECM and harness are okay. The fault can only be in the evap solenoid. If you don't have access to an oscilloscope, the test can be carried out using a multimeter set on duty cycle. With the ignition off, disconnect the evap solenoid connector and identify the control circuit. Connect the meter set on duty cycle between the control circuit and battery positive. Turn the ignition on and using the scan tool, actuate the evap solenoid. You should see the duty cycle reading on the meter mirror the requested percentage from the scan tool. If your meter does not have a duty cycle function, this test can be checked with the meter set on volts. With a 50% duty cycle command, you should see approximately 6 volts. 0 volts may indicate an open. If no reading is seen, move the meter test lead to the ECM and back probe the correct terminal and repeat the evap activation procedure. If the correct meter reading is displayed here, then there is an open between the two connectors. Repeat this procedure at any other connector in the circuit to isolate. If there was no meter reading when back probing the ECM, then turn the ignition off and inspect the ECM connector and terminals for correct terminal tension and corrosion. If no fault is found here, then the ECM will have an internal open. If the circuit tested OK, then the open is internal to the evap solenoid. The duty cycle function cannot be used to check for resistance. Even though the voltage is low, the duty cycle may still be correct. Connect the meter set on volts between the control circuit and battery positive. Turn the ignition on and using the scan tool, actuate the evap solenoid to 100%. The meter should read battery volts. If the meter displays an incorrect or low voltage reading, then this is an indication of excess resistance in the control circuit. Move the meter test lead to the ECM and back probe the correct terminal and repeat the evap activation procedure. If the correct meter reading is displayed here, then there is excess resistance between the two connectors. Repeat this procedure at any other connector in the circuit to isolate the fault. If there was an incorrect meter reading when back probing the ECM, then turn the ignition off and inspect the ECM connector and terminals for correct tension and corrosion. If no fault is found, then the ECM will have internal excess resistance. If the circuits test OK and the ECM is producing a correct PWM voltage, then the fault will most likely be in the evap solenoid. To confirm this, perform a resistance check between the two terminals on the evap solenoid and compare them to specifications if available. Once you have repaired the fault, clear the fault codes and perform the correct drive cycle for the DTC. Remember, understanding system components and operation makes diagnosis simple. Thanks for watching.